Okay, so this is a set of notes on angle relationships and circles. I'm actually working from Sketchpad today because I think it's pretty easy to demonstrate what I'm trying to do if I'm working from Sketchpad. So let me get a circle here. Okay, oh, there we go. There's my circle. And I'm gonna get rid of that control point and hide it a little bit so I can show what's going on here. We've seen some things in class. We've seen okay, the first thing I'm going to do is actually just build a couple of chords here. Oops. Let's do this again. Sorry, little wonkiness. I'm going to build a couple chords here. So there's 1 and there's 2. Okay. I'm a little leery of the first one. Make sure that that's not where I want it to be. Let's try that one more time. All right, so click off into nowhere, build a couple chords. There we go. That one's on the circle. So is that one. That one's on the circle. So is that one. Okay. And what I want to do is to hit the point of intersection here and make a couple of angles. So I'm going to measure this angle here. All right, so we're going to measure that angle and it comes out as 111.05 degrees. And I'm going to measure this angle here and it should come out as the same because those are vertical angles. Okay, so if I take this circle and I measure the arc AB, right? So I'm going to measure that arc angle. That's 90.85. And then I take the circle here and I measure the arc DE, right? So that measure is going to be 131.24. And if I look at this, what happens is I'm going to break out the calculator here. So I'm going to take number, calculate. And if I take this angle plus the other angle, so this is the two being intercepted, right? And take the answer there. So I got to put parentheses around this, right? So the parenthesis there, I need the parenthesis here. And I divide that result, give me a division sign, by 2. Lo and behold, that answer is 111.05, which should not surprise us, okay? Because this is the same as these two angles. So what did we just say here? We said that if I take this arc and average it with this arc, then that is equal to the measure of that angle and the measure of that angle. And I think I should be able to grab this point and move this about a little bit. And no matter where I move that on the inside, these two angles still add and divide by 2 to give me that, or those two arc measures give me that internal angle measure. And remember, like if I put this right at the center, then the angle, it's not quite at the center there, right? So let's try to get it as close as we can. There we go. The angle measures here should be equal to these because that's the central angles, right? So now the question is just like, does that work everywhere? Seems to work everywhere here, but if I bring it, like, the problem is going to be is that if I do this and I create a situation where that intersection is no longer inside the circle. So if the intersection is inside the circle, I add them and divide by 2. Okay, so let's start a new sketch. Okay, and I'm going to build a circle here. Okay, so there's my circle. Whoops, there we go. There's my circle. And I'm going to hide this point here because I don't want to deal with it. And now I'm going to build 2 segments. But this time, they are going to intersect, but they're intersecting outside the circle. Okay, so let's find these points. There's one there. There's one there. All right, so when it was inside the circle, I could take and find this angle. Whoops. There we go. This angle here, right? By finding the measure of this arc. Let's find the measure of that arc, right? And find the measure of this arc. So the two intercepted arcs. Oh, gotta name the circle first. The circle, there it is. And then the intercepted arc, there it is. Okay, and measure crud. One more time. Here we go. There we go. Measure the arc angle. There we go. So I've got these two numbers, right? So in the last time when the intersection was inside the circle, right? Oh, number, calculate. What I did is I said, okay, take this one plus the other one and then divide by 2. And I was supposed to get the measure of the angle, right? The angle. So let's see if that still works. And lo and behold, let's go, oh, there we go. 3, measure, blew it. There we go, 1, 2, 3. Measure the angle, and lo and behold, it does not work. These are not the same numbers. So when the point is on the exterior of the circle, I actually just have to tweak this slightly. So we're going to edit the calculation, and where there's a plus here in the middle, oops, sorry, let's cancel that. Let's try that again. Where there's the plus in the middle, I'm going to change that to a minus. And when I do that, I think I have these in the reverse order. I got the negative, right? So basically, the right idea here is that I'm subtracting them and dividing by 2. Let's be a little bit more cautious here. Let's go number, calculate. What I probably should have done is taken the big one, parenthesis there. And not plus, but minus the little one, and divide by 2. Okay, so there we go, and we get the actual right number, just that we had them in the reverse order. So let's kill this one off and work with this one. So if I subtract these two arcs, right, so this is the big one out here, and this is the little one in here, and divide by 2, I get the angle measure for this, right? So again, when the point is on the inside, add them and divide by 2, and you'll get the angle measure. When it is on the outside, right, and I can move this thing around. I can go and grab this, move it around, and these things still work. I move it to the inside, it's weird. So I go outside, it still works, and these numbers will always line up, the 28.74 here and the 28.74 here. Inside, add them and divide by 2. Outside, subtract them and divide by 2. That's the upshot of working with angles and intercepted arcs.